So we're going to talk about chemical bonding. So chemical bonding is when atoms chemically bond, so come together, in an attempt to be stable. Okay? So the octet rule tells us that atoms need 8 valence electrons to be stable. Every atom on the periodic table follows the octet rule, except these 4. Okay? So hydrogen, helium, lithium, beryllium, the first 4 elements on the periodic table are so small, they're so little, that they only need to follow the duplet rule. So they need 2 atoms to be stable instead of 8. So 114 of our 118 elements are going to follow this octet rule. The first 4, hydrogen, helium, lithium, and beryllium, are going to follow the duplet rule instead. Okay, so in order to be stable, atoms are going to gain or lose valence electrons. So they want 8, except for the first 4, who only want 2. But in order to get 8, they're going to either gain or lose valence electrons. So they're going to do this through ionic bonding, covalent bonding, hydrogen bonding, or metallic bonding. So those are our big 4. There's a couple others, but these are the big 4, the 4 that really occur frequently. All right, so the first one we're going to talk about. So this is ionic bonding and pop-up vocab. So before we talk about an ionic bond, we're going to talk about an ion. So an ion is an atom that has a charge. So when we don't have the same number of protons and electrons in an atom, we're going to have a charge, right? It's either going to be more positive or more negative. In most cases, protons and electrons are going to be equal, that's going to cancel out. But when an atom becomes an ion, we're either going to have more electrons or more protons. So if we have more protons, it's positive. We've got more positive than we've got negative, so it's a positive ion. If we've got more electrons than protons, then we've got more negative than we've got positive, so it's a negative ion. So that should be pretty straightforward. So in ionic bonding, we're going to have 2 atoms become ions. So metals are going to give non-metals valence electrons. So 1 or more valence electrons, a metal is going to give away. So the way this works, metals typically only have 1 or 2 valence electrons. So it's way easier, it requires way less energy to get rid of those 1 or 2 than it is to get 6 more, right? And because we already know that every other shell is full, to get a full shell, you just got to get rid of that extra 1 or 2 that are causing that extra shell, right? So metals are going to lose an electron. They're going to give away 1 or more electrons to that nonmetal, and then that nonmetal is going to be able to fill its valence shell. So for instance, in table salt, so sodium chloride is table salt, sodium has 1 valence electron, right? So it's got all these shells that are full, and then it's got 1 valence electron, and that 1 valence electron creates a whole new shell, right? Chloride has 7 valence electrons, so chloride needs 1 more, and sodium has 1 too many, right? So sodium's going to get rid of that 1. When sodium gets rid of that extra, it's got a full outer shell now, because that valence shell doesn't count anymore because it has 0 electrons in it. And our chloride is then going to get the valence electron it needs. So we go from having 1 too many and 1 too few to having just the right number in both, right? So now that they've each got this right number of electrons, we're going to see that sodium now has less electrons. So now it has more protons than electrons, more positive than negative, it's going to become positive. Our chloride is going to have more negative because it's adding an electron, so now we've got more electrons than protons. It's going to be negative, and negative and positive are going to attract, and that's ionic bonding. So ionic bonding is a bond between 2 or more ions. So metals are always going to give nonmetals valence electrons. So that's our big one, right? Covalent bonding is our other really important one. This is the other one we definitely need to know. So covalent bonding happens when 2 or more nonmetals are going to share valence electrons. So we've got 2 or more nonmetals that are going to share valence electrons. So they're going to be buddies, sharing is caring, right? So In water, for example, we've got oxygen that has 6 valence electrons. Hydrogen each has 1. This is 1. Hydrogen each has 1 valence electron. So oxygen is actually going to share 2 of these, right? So when they share these, hydrogen is then going to have 2 because it'll share 1 with oxygen, right? And this hydrogen is also going to share 1 with oxygen. So now all of a sudden oxygen has the 8 it needs because it's got 6 of its own, plus 1 extra from each hydrogen. And hydrogen is each going to have 2, because remember, hydrogen is one of our 4 elements that follows the duplet rule. So now that hydrogen each has 2, everybody's stable, right? But the only way that they can remain stable is to continue to share that bond and continue to share that electron. So when we compare these two, this is what these bubble clouds are. These are comparisons, right? Compounds that are formed with ionic bonding are going to conduct electricity, they're going to have a high melting point, and they're typically going to be solids at room temperature, like table salt, right? Covalent bonds, or compounds formed through covalent bonds, are not going to conduct electricity. They've typically got a low melting point, and they're typically liquids and gases at room temperature, like water. All right, last 2. So these guys are they're very abundant in nature, but they're slightly less prevalent right now, right? So hydrogen bonding is going to be where 2 or more hydrogen atoms within a compound or molecule bond. So we talked about how water is formed with a covalent bond, but when water is formed with a covalent bond, it becomes a molecule, right? So that's where that word molecule comes in, and pop-up vocab. So a molecule is a compound that's formed with a covalent bond. So if it's a covalent bond, it's a special type of compound called a molecule. So table salt is not a molecule because it's formed with an ionic bond. Water is, because it is formed with a covalent bond. So hydrogen atoms in a compound or a molecule like water are going to bond to each other. So these guys are going to be attracted to each other. So I've got one covalently bonded water molecule, another covalently bonded water molecule. Those hydrogens are going to be attracted to each other, which is actually how we get bodies of water. All right, and then metallic bonding happens when metals are going to bond with other metals. So metals, particularly our transition metals, tend to have more free-flowing electrons, and metallic bonding occurs when those electrons are able to move freely in between atoms. And that free movement of electrons in between atoms is actually what's going to create electricity. So metallic bonding, very important. Hydrogen bonding, very important. This is how we get water and electricity, but we're going to spend less time on those in class.